evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. Welcome to the show. It is Free Energy Friday. Somebody's got a really loud background noise. Is that you, Bernie? Somebody did.
That was good. That definitely wasn't me, but I love the new intro, and I love that that's muted now.
Oh, thank you. Okay. Yeah. Welcome to it's Free Energy Friday. Welcome to the show. It's Friday, February 20th, 2026. Welcome to the show. That's my new intro music. Actually, I purchased years ago. Just a quick little story here. Years ago, I used to make my own bumper music for my conspiracy show, and I stumbled upon this awesome software that I used years ago, and I decided to buy it again. And the software is called Reason. Anybody who's into creating music and stuff like that, Reason is like one of the best platforms out there for creating music and your own original stuff. And that's why I'm using it, so I don't get flagged for copyright. So that's what I've been kind of working on in the last week or so. I'm trying to learn the software again because it's been over almost 20 years since I used it, right? So yeah, so I'm going to be making some more bumper music. I got the software now. It's really awesome. The subscription, I think it's like $20 a month, and you get full access to all the plugins, all the they got refills of sample music and all that stuff, and you can make some really neat stuff. So been playing around with that. And to boot, working on the battery stuff. That's an ongoing process. I'll talk about that later in the show. We have Nathan on tonight. We got Mr. Philip in Montreal. We also have Elijah joining us tonight.
San Diego.
Philip, your background noise is killer. Yeah, like there's a TV going or something. It's really overpowering. Yeah. So I guess we'll get the show on the road. Nathan, I know you've been working on the Renegade device and Bedini motor, and you've been doing a lot of stuff in Fusion there, and creating your coil holders and your core inserts, so you can actually shove in your rods in, without shorting them out. Really cool stuff. I really like what you were doing there. Kind of, if you want to go over, you also had a good podcast with Papa Bayo. I enjoyed that. So yeah, maybe just kind of give us an overview of your last week and what's going on.
So what it is I figured if we're going to do the pulse motor, I might as well do it right. So I built a Bedini and tried to keep it as close as I possibly could to what he did. Just make a few little edits for my own self. And then also, Mike, your Renegade device to get the pulse motor there. So Papa Bill was on. We're looking at his pulse motor and everything, going over it, because he's got smaller coils. You got bigger coils. You run a core. He doesn't run a core. So the big differences in how they actually run. And without knowing how they run before I even built one this time, you know what I mean? I needed to know all the information. So between you and Papa Bale, it's been awesome. I've been able to work through a lot of the challenges that come up in these things. I'm almost done with the Renegade device. It should be out by the next week. All I got to do is screw a couple things to the board and it's done. And then I got all the wiring and the schematic checked out with you last time. I turned on the coil, put about 24 volts in it. Got the thing to spin. So we're actually doing good on that. So I got to share some STL files with you now that it's at that point, you know what I mean? So you can have them for whatever you want.
Right.
And then, it's just going to be adding a second or third coil to some of these things to see what I can do, what I can pick up, what's the best pickup size. I want to see the piezo's in action because I know with my Tesla coil, I double the voltage in it. So I wanted to see how it saturated the core in the, the big core that we built with the 2 pounds. So that's kind of
it'll be really cool when you feed off of that to isolation transformer, and
Mhm.
you dump it into a full weight bridge, and then put it in the big blue cap. Actually, I have one here. Um, this one here is 60 volts at 16,000 microfarad. They're quite large. These are
Mhm.
capacitor to use because they're like self healing. So you can really hit this with a lot of voltage, and it just absorbs it. I do have capacitors that can handle what is it, 2,800 volts DC.
Mhm.
So they're the big oil filled ones in the gray canisters. So I got some pretty heavy duty capacitors to work with. And what will be really cool is when you put it through the full weight bridge into a capacitor, put it through the full weight bridge again, and then pump that power right back into the same battery that's running your motor, and
Mhm.
it won't short out. And now you're going to also see a reduction in the amount of current that it takes to run your Renegade. It's going to go down.
Nice. That's what I'm
So,
hoping for. I want to see how close it comes to over Unity, or if it surpasses it. You know what I mean? I want to see what the tweaks are that we would have to
well,
make or whatever.
like a perfect example, I had a set. I was actually, some of my tests, I just used the small 9-volt batteries, and I would put like 6 or 8 of them in series.
Mhm.
They would last 6 months. They wouldn't die. So, like, I would, obviously at the end of the night, you would shut the motor off. You would, come back in a couple of days and you fire it up again. I'd go for 6 months and these things are still working. You know,
Nice.
they're technically quote unquote dead, but that's the beauty of the Renegade device. You can run the Renegade off of dead batteries. So, you know what I mean? Like, how cool is that? Running an actual device to create more power using a power source that's
It's
technically
not
already dead.
necessarily dead. It's more negative energy that it's running off of.
Well, it's flipping it over into negative energy, right? So,
Well, you're charging it and you're discharging it, and the plates in there are carrying the energy through it. But it also, once it builds the field on the inside, it allows you to push back and drive a load with it.
yeah,
That's the beauty of it. That's really what you're getting, is the ability to drive a load out of
yeah.
it, because it's charging
Well,
and discharging.
yeah, because you want to keep that system, because it's a closed system, you want to have a way of tapping off that closed system in a way that's not going to kill the dipole, as Tom Bearden would put it. So in series, I would hook that up to an isolation transformer. And now I'm using the flux that's created in the isolation transformer to pull potential from that closed circuit without killing the dipole and not killing it. It's running, it's doing its own thing. Now
Mhm.
I'm able to extract power off that to do something else without killing the dipole. So Bearden talks about that extensively,
Mhm.
not killing the dipole.
And I
So
actually wanted to go into that a little bit tonight too, because I've been
sure.
reading about that, and that dipole is already a form of asymmetrical regauging that is structuring what he calls virtual particles in the vacuum fluctuations. So the
Mm,
cross product of any charge is not just your zero vector, 0 point, but it's also plus a sine WT. And that is from the oscillation of all charges. And so what we're accessing is basically all those little transient fields through the dipole that is structuring that into a magneto-hydrodynamic flow structure of the wheel within the wheel within the wheel, as seen on Martin Fleischmann Memorial Project.
Mhm.
right.
And he talks about time reversal zones, specifically on the positive terminal, or in elemental transmutation or cold fusion, you're basically converting time energy into expanded spatial energy. So you have a low density energy spatially, but you have a high density energy in the time domain because your delta E times delta T is equal to your constant H. And so basically when you work on these displacement currents switching at a high frequency, right, of your dielectric field, that builds your displacement current density. And we're actually getting into what static electricity actually is, because that time reversal zone is allowing like charges to actually attract. And that's truly what your motor and the Bendini motor is actually doing, that allows it to run off of like a dead battery. It's a positive feedback loop of static electricity inside of a battery through a bell boosting method.
Right. Now, also too, Bendini talked about the actual chemistry in the battery that's actually affected by this field, the static charge. Now, in one of his videos, it's actually in Energy from the Vacuum series, where, you know, the neon bulbs. So when he had one of his motors running, he had one on the positive terminal, and the ground was touching the plastic part of the battery. And guess what? The light was starting to shine. And
Yep.
it takes 90 volts. It takes 90 volts for that light to go on. It's a neon bulb.
Mhm.
So there's a field actually being created in the battery itself because of that static or, you know, etheric power that's going into the battery chemistry, right?
It's the radiant fields. All dipoles are accessing the radiant field.
Yeah, that makes total sense. Because when I seen that, I go, there's a field going on there. That was the first thing that came to my mind when I seen that. I go, he's actually polarized the entire battery with this field. Which I'm looking at him going, that's cool. I've never seen anything like that. That was the first time I saw something like that. It's like, yeah, that makes total sense what he's doing. So I'm kind of curious.
Sorry, can I do my pitch, because I need to. I cannot talk the whole show. I'm just gonna listen. So I'll just do my pitch right now, and you guys can go ahead.
Yeah. Okay.
Yeah. So I just want to say that I did a lot of research for the last 15 years on how to get funding and things like that, and like I was saying, before the show, like Canada, they have grants, but they they change it every 6 months, so it's not consistent, based on the discretion of the government. So it turns out to be useless, And in United States, they have the program SBIR, STTR, for all businesses. You just need to find a solicitation, and they have the DARPA program for deep tech research. So they're very generous. There's a lot of there are some bureaucracy, but they're very consistent compared to Canada. So if anybody is looking for funding, that's the only way. That is the only way. Whether you like the government or not, that's the only solution. There are no other solution, And you don't have to have a patent and all. They're not gonna steal your ideas and all that shit.
Unless you have a really good friend that's like a multimillionaire.
No, but
Angel investor.
yeah, no, but just saying, Americans should take advantage of that, and people should stop complaining that they don't have any funding and all that. There's a lot of solution here, and it's very consistent. And I think Americans should be proud of their country, because Canada they're not going to invest in risk. Not only their system is not consistent, but they don't invest in risk. So that's why it's not a credible country, So it's very simple. And what I say is very short. I'm not going to talk for 2 hours about it, but took me 15 years to figure it out. Quality over quantity. That's how I think. And yeah, so sharing that with you guys. So if you're looking for funding, then start your own business in the United States, and you will have funding. You know. So
So I kind of disagree with you, Phil, because look at what happened to John Bendini, right? And like any sort of efforts to try to legitimize it through
Oh,
TUV, they didn't
Stanley
even
won.
write a report, right? And the Treasury Department will say that if you threaten the U.S. economy, that you're a threat to them, and they will consider you as committing treason, and they will destroy your life or kill you. And so I kind of disagree with you, Phil, because they
well,
keep people poor and in certain positions by design. And if they can't do that, and if their threats don't work, they'll just get rid of you.
yeah,
Well,
but
you know,
this is the discretion factor. It depends on which party is elected, but there's a discretion factor. But you know, the correct there is corruption all over the place, and I agree that um, the case of Epstein, even Kurt Cobain was Courtney Love was part of the Epstein ring, and I think they
Oh wow.
yeah, he never got committed suicide. That's for sure. He got killed, and I think Courtney Love was part of the Epstein ring 30 years ago. So um, yeah, these are bureaucrats, the elites, and all that shit. Um,
yeah, we'll leave
but
that for another show, Phil.
yeah, but I'm just saying, it depends on the
No,
use case, who
all
who
right.
who's elected, but there's the discretion factor. Like I was saying the other day, the discretion factor. I think it's a margin that if they like you, depending on who you elected, then they will make your life miserable or not. So if you match if you voted for them or not, then you will be their
You
ally
want to
or
hear? You want to
their
hear
enemy.
something really crazy that just happened right now?
Always.
As we have the live chat going right now, everyone live chat's going, and I wanted to say welcome everyone. Guess what happened?
Wow.
My screen where I actually made the post says YouTube rejected your comment. Um, thinks it usually means they think it's spam for saying welcome everyone. Can you imagine
Understand?
that? Like what the hell?
Comment your own lives.
What the heck is that crap? Welcome everyone, and I got flagged.
Oh, put a rainbow next to
Well,
it. You're in Canada. You'll be all right.
My God, what the heck? That's the first. That's a first. That's never happened to me before.
Hello to everyone, and stop being so welcoming, you darn Canuck.
Yeah, yeah. It's a crime. Oh my God.
yeah.
Really?
But anyways,
Uh,
Canada is not the solution unless you can bootstrap your company. Then you're good. That's the perfect solution is to bootstrap your own company, but it's not very easy. Um, but that's what I'm doing, and I'm very positive it's gonna work. I'm not gonna require investors and all that crap because I'm not gonna own anybody any money. So that's pretty good, but it's not easy. It took me 15 years.
Sold to the American military, but that's okay. I'm seeing a lot of rainbows with these goggles. Nathan knows what I'm talking about. Oh man, it's
The
not
heck are
live.
you wearing? You look like you're welding or something.
Right? Well, it's like it splits the light into all the different colors and rainbows, and they're interesting, but not great for podcast. You can't really see anything, so I'm just gonna mute up. Shut up.
yeah, I
But all I can say is if they send men in blacks on me, then they better not miss their shot, man, because they're only gonna have one chance. That's all I can say.
Hey, don't put
Phil, I
that
thought now you're part of that Men in Black. you know.
You saying one shot on me? Shit.
Philip in black.
I'm a spy, I guess. I'm spying on you guys.
MK Ultra Philip.
Yeah.
All right, I'll let you guys go. That's all I want to say. Cheers.
All right, Phil.
Right on. Yeah, it's not the fact that you get funding from the government. It's what is the government going to do with your research? You know what I mean?
Yeah.
That's what really gets me. Some of these fields, you know, they probably already have it, but I don't really want to contribute to that.
Yeah, but
because it's definitely a weapon.
All I can say is the best way to win a war without fighting is by deterrence. So if you have the best technology, nobody will want to fight you. You know, that's,
No,
that's the only solution.
Well, the other thing too is everybody wants to get patents and everything. The only thing that the patents are useful is the military, because if they have, say, for example, a free energy device, what they'll do is they'll file for the patent. They'll bypass all the red tape of Section 14 of the Secrecy Act of the U.S. Patent Office. They'll give the patent, but it only could be under the control of the military.
Mm-hmm.
Right?
Yeah, but I mean, if a patent doesn't work, then the only solution left is to bootstrap your company. You know,
the other thing too is, you know, the patent office will only patent stuff that they know in their science that it works. So if the military puts out, say, a free energy device, like I was saying before, and they patent it, well, obviously they've patented it for a reason, because they want it for themselves. And because it's the military, they could bypass all that Section 14 of the U.S. Patent Code Secrecy Act, that they can legally get it patent. So now it's under the control of the military. Right?
Yeah, the military ultimately is all they care is to have the best technology regardless. So they'll do it one way or the other. So you might as well.
So like for me, like you know, in a lot of inventors, patents are kind of useless to us because it's rigged against us.
Yeah, right? Patents are useless. Trade secrets are better. Trade secrets are better because, you know, you just don't tell anybody.
Well, there's other things too. You can copyright stuff or trademark stuff. You can go different routes.
Copyrights and trademarks are useless.
Yeah.
Trade secrets are better.
Dead man switches amongst your peers.
Well, and then, you know, a lot of guys out there are into, you know, basically open source, right? Free for everybody. So I kind of feel like that for a lot of stuff I do, but there's some stuff that, yeah, this is my intellectual property.
I share 90%. I share 90%. 90% of finite theory, and PhDs they just cherry pick from it and they take credit for it. That's what happens. So I don't have any credit. Tim Ventura banned me. So, you know, fuck everybody, you know.
Yeah, I know it's discouraging, but you know what? Well, you look at it this way, Philip. If one door gets slammed in your face, other ones are going to open. So you know what? You know, the other group, I'll say, I won't even mention their name because I don't want to use their name, but I don't worry about them. They're irrelevant to me. I don't give a rat's ass about them or anything that they do. I really don't.
Well, I care if they are committing espionage and potential treason to foreign governments, but that's a topic.
Yeah, but Bernie, I'm not Superman. I'm not going to come and save the day. You know what I mean? Like, I got too much.
My job, that's you're right. I like it. All right.
Like, you know, I got better things to do with my time. Honestly, you know, I got family. I'm a father. I like what I do in my free
Yeah,
time with
I will talk to you. I will give you all the evidence that I have collected. If you want to investigate this, I do not have children. I have many distributed dead man switches, so you cannot disappear me, but I will cooperate.
Mm.
my.
He just got done saying he didn't want to do any of that.
What's that?
You just said that you didn't want to do any of that. He's not going to look that up, Bernie. He's Super Mike. He doesn't do that. He's family man.
Yeah, you know what? I don't
I'm seeing
care
myself.
about that. I really don't. That's conspiracy world for me. And you know what? I have more important things to worry about. I do my thing. I run a show. I do my science, and yeah, that's where I keep it simple. I don't try to make my life complicated like that.
We like Mike being alive because I remember when we started out, there was SUVs like trying to hit you on the highways and stuff because you were putting out a little bit too much, and you
Well,
got unemployed and stuff.
I
They were interfering with
yeah,
your contracts. They were doing all sorts of stuff to silence
but
you.
but Bernie, I don't talk about it every show. I maybe mentioned it a couple of times in the past, but I'm not talking about that stuff every day. I don't base my whole life on those weird things that happen. Yeah, it happened, whatever. I just keep going forward. You know what I mean? It's if you have a beef with the other group or whatever, keep it off air because it's not going to help anybody. Concentrate on what we do here. We talk about our science, we talk about our ideas, and that's it. That's what I want to keep this show about, is the science stuff, what we were talking about
They
earlier.
say gossip is the least form of intelligence.
Exactly.
Big
So
minds, talk about ideas, small minds talk about people.
so let's keep it on the science, and yeah. So
Hey, Mike, if it makes you feel any better, I don't have time for that stuff either. I
yeah,
literally don't. And Bernie
yeah.
knows I'm running ragged as it is.
Hey, we were just building nonstop over there for 2 weeks straight, running experiments, filming. I can't wait to get back.
That's right. And that's the way it should be.
Yeah,
Don't
that's
worry
what
about the other people. Don't worry about them. Worry about what you guys are doing. Worry about you, right? And that's it. And your life becomes a hell of a lot easier after that,
Mm-hmm.
right? So let's get back to the science.
absolutely.
So I want to know the
Like-
science of how Bernie does this. Like, he smokes 2 packs a day and climbs mountains. I need to know the science behind that because that's not normal.
Eating silver copper water and consuming monoatomic gold that has reflected light in it, and somehow it works magic, and I somehow smoke 2 packs a day and climb mountains.
I did that up a friggin' volcano. I had a cigarette hanging out of my mouth. I had 2 backpacks on me. I was like a friggin' donkey.
Right?
Then.
I guess it's just a Canadian thing. We're born tough and rough, and we smoke up mountains and volcanoes that explode somehow.
My wife and her girlfriend are about 100 meters behind me. I'm halfway up the friggin' volcano in the Philippines, and I got 2 bags on me. I got a friggin' cigarette hanging out of my mouth, and I look back and I go, "Can you guys like hurry up?" And then our tour guides, the guys that were taking us up, they were riding donkeys. I was a donkey that day.
Clip that.
That's great.
And I got pictures to prove too.
Well, hopefully you wore your pants unlike the donkeys.
Yeah, I had my pants on. Yeah.
Just let it all hang out.
Yeah, sticking my ass out. No pun intended.
That's funny.
Oh, that's funny. I wonder why you're so far ahead. There was a trail. They're like, we need to stand 100 meters back from this ass.
Yeah.
We're getting blasted over here.
Hey, my ass was a lot smaller back then than it is now.
Oh, that's funny. I'm sorry, Mike.
Yeah, it's all right. Anyways, Let's
Get to the
on
science of how that works.
Exactly. So, Elijah, yeah, we were talking about the Bedini and the battery. And so, what do you think's happening? Is there like a static charge being created around the battery itself from the negative energy, or?
So I think the accumulation of charges on the positive terminal is
Mhm.
a time reversal zone, and that's what allows the heavy positive ions to stick together, closer together. And I know the battery is ringing like a bell, and it will
Right.
ring at its own resonant frequency no matter how fast you hit it or how hard you hit it. Now, if
Actually,
you
as a
want it
matter
to
of
be
fact,
more coherent, if you want
as
it
a
to
matter
be
of
more
fact,
coherent and resonant, you have to
mm,
time it, right? So that's
mm,
what Bendini was trying to do, was time what he was hitting and trying to charge a larger dielectric field sink with the smaller dielectric field sink, which is why TUV would not share the results in the report.
right. Now, correct me if I'm wrong. I held up I have a Tesla magnetic field tester. It gives me registers the amount of Tesla that's in the magnet. I actually put that near the battery, and the battery was giving off a magnetic field.
Right. That makes
Interesting.
sense. So the magnetic field is the two E fields, 90 degrees orientation to each other, cross fields, right? And that's
Yeah.
what creates your
Exactly.
magnetic component. And your magnetic
Now,
component is really just the spinning of the charges. And all charges will spin because it's already in a magnetic field of Earth's magnetic field. So
right.
now you're
Now,
just making it like a cyclotron resonator and reducing the mass of the electron the more it's spinning,
right.
which is
So I
actually a
did
form
know
of ultramagnetism.
what I wanted to add to it too. After I shut the power off, it was still doing it for about a minute or two after. So when I shut the motor off,
Yeah.
that battery was still ringing.
Well, the dielectric is a key component there that he said. That's what's giving you your light bulb to turn on. That's the field that's doing it. I do it all the time. You
Yeah.
split an orange in half, and it'll go right through the center of the orange, light up light bulbs all day long. That's your dielectric field. That's the one that's turning on the light bulbs. It's not the magnetic part of it.
Yeah. Yeah. Interesting.
But it's the magnetic component of all of the universe that's feeding that dipole
But it's
through
trying to
the
pull
little
it's trying to pull the
perturbation.
magnetic in.
Right.
Yeah, exactly.
Yeah, I agree with that. Absolutely. I think he saturated the living daylights out of that battery. Is what I think he did, and it would make the holes and stuff in there fill in with energy. If there was holes in the plates, it would.
Desulfate the plates.
Yeah, everything. It's same thing as you do with the center of a Tesla coil stuff. It has the same dielectric signature to it. It does the exact same thing.
And on a material science level, when you have cracks and you vibrate them, the little voids want to come together, and it's crack propagation what happens. And when you have a hole and another hole coming together, that actually can make a phase, basically a scalar wave, like a North Pole and North Pole coming together, which is like a phase conjugate wave, like the Bethe-Hilter process. And that process will actually spit out a Cooper pair of electrons. And so the combining of holes in a type P metal or semiconductor will actually produce extra electrons out of your system. And that's why when you have a PNP transistor and you oscillate it with a voltage on one side, the load will actually see a higher voltage than the voltage you're inputting in its magnitude. And the
Exactly what
sun is actually acting like that as well. The sun is a PNP transistor.
We know you said something extremely important because Phil returns.
Yeah, I thought Phil
This
was in the
means
dark earlier.
anything to anybody.
Analyze.
The sun is actually has a giant hole in it right now, coronal hole.
It's shooting out massive paired Cooper pairs,
Yeah.
right?
It's coronal hole is facing us right now on the sun. I kind of follow the sun and the activity.
So what does that
it's
mean
been,
for us, Mike? When it has the hole facing us?
There's going to be more.
It's showing instability. We're right now in a cycle right now in the last 2 weeks where it was actually spewing out a few X flares. The largest one that I recall was X8. So that's pretty powerful. So if that
more auroras in the Canadian skies is what the forecast says, basically.
well, also disrupt radio communications. Any satellites like Starlink or whatever get fried. And they lost, I think, what was it, 19 satellites they lost in the last 2 weeks. So that could have been a result of these flares hitting, our ionosphere and disrupting our magnetosphere that protects the Earth from cosmic radiation, right? So every time a flare comes out, depending on if it's going off to the side or if it's coming directly at us, is kind of a key thing. But
Not only that, it disrupts like the wildlife migrations. Like it throws them off too. Like,
well, the sun actually affects all living beings on the planet. Whether you like it or not, the sun is very important to the human physiology. Very important to plant life, the animal life. Any living being on the planet is affected by the sun. Fact. So, we're not like sun worshippers or anything like that. But the sun definitely, and even Eric Dollar talked about it for years, saying that the sun is very much a very huge part of the human physiology and our energy system, how certain vitamin A, certain vitamins in our body get activated because of sunlight. And in the winter,
vitamin D is also essential.
Vitamin D as well. So the sun's a very important part.
Like bees get
So let me ask
affected,
you a question.
Quite a bit. Go ahead, Elijah.
So I was going to ask, if we get affected by the sun, does the sun get affected by us?
Good question.
I believe the answer is yes.
Well, do you think that we put off enough of a field to affect it, though? I mean, individually, if we were all together in the same one.
Like, no one really
I think
knows exactly. Sorry, go ahead, Elijah.
Well, I think the ether is a living conscious field, and we're made out of matter within that living conscious field. And I think that plasmoids are also conscious because that's what makes up all matter. So I think that we can actually alter and affect the sun, even without technology, but even more with technology, and even more so with cosmic alignments like we're in right now, which is 30 in the last. We haven't had an alignment similar to this since like 36 years ago. And there's like other cycles within that, right?
Yeah, that planetary alignment's coming up soon, isn't it?
We're in it right now. We've been in it, and that's what's making this big giant hole right now.
Yeah.
And the magnetic field lines come out of that black hole, coronal black hole, basically, that sunspot, I should say. And
Yeah,
the magnetic field lines reach all the way to Earth and tie into our magnetic field lines, and that's what allows the plasma to flow back and forth. And you'll see that the sun has green and red plasma just like the auroras on Earth, because it's actually the same plasma.
like Eric Dollard years ago, he did a 4-year project studying the sun at Sonoma State University, and it was pretty well determined, even at when he worked at RCA, that the sun is hollow. It is not a solid object. It is hollow.
I believe that. Just like the moon rings like a bell.
Like everybody thinks.
I don't believe that.
I kind of see where he's coming from on that. I personally do not believe the sun is
When you
solid.
get the corona hole, it's just a giant gaping hole into what looks
In
like
the counter space. It's counter space. That's what he describes. The inside of the sun is counter space. It's an electromagnetic converter. That's what he calls it. He says we will never really know exactly what the sun is and how it works because just because the heat and our
We do. It's called black hole sun. Soundgarden got it right. Black hole sun.
Not a black hole.
But
my God, let's go backwards a million years.
No, but look at a sun. What happens when a sun dies? It collapses in on itself.
But at first it explodes.
Yeah, it's an implosion. Well, it explodes and then implodes.
Right. So it's implosion. The sun is literally an explosion over time. That's all it is. The time dilation field slowing down the explosion and going out on the sun. And eventually it's going to hit and explode the sun. Then it's going to go back down to its mass of whatever's in it. So when you get that little dwarf that comes out of it, there's your mass. So it can't be hollow inside. It's got mass. It's going to convert all of the plasma into mass. So I'm sorry, I don't think it's hollow inside. As a matter of fact, we did some experiments on the RAV, and we found out there's dots inside. It's actually formed the shape of a Merkaba when they come together. So there's little spherical shapes in there, and it forms just like an atom. So we actually got to see what it looked like inside when it formed immediately. It showed it, and it's a prism. It's simply a light prism, and we got to start understanding light turns into plasma, and plasma is what the sun is, which is the explosion over time. You got to just understand
we just went
time
full
dilation.
circle back.
I'm sorry, what?
Say that again.
We just went full circle back to static electricity, and you were about to say time dilation, and that is the time reversal zone that enables those nodes to form.
Yeah, it is. It all ties in together. If you can understand the loop, you're good to go. Yeah. So it may appear that it's hollow, but it's not. So.
Yeah, I don't know. I'm still on the fence about that.
We've even done
we can agree to disagree.
Oh well, no, it's fine. We created a RAV and it created a beam. So it's our focus beam. It goes and hits another a little element sitting there in nowhere, right? It seems like nothing's there. It hits it and it sets a condition. So it creates a sphere around it. So it's basically set a condition inside that area. So if I slowed that thing down to a microcosm of the speed that it was going, it would act just like the sun inside there. It would act just like a big pulse over time, and then it grows, but it immediately sets a condition in space of where it's at. And we've seen it very clearly in plasma.
Yeah, I gotta agree with that. And that if you haven't been following the RAV Plasma series, just for one episode, what we just finished earlier today, and what Nathan did with Joe, and I got to be part of, covered a lot of it with Sean Calderon's work and Joe's work, and just the imagery. It just over and over again shows how it sets the condition and builds out within it. And it always is the field within the field within the fields within the fields.
So check this out, Mike. I sent you a picture. Tell me what you think.
Hey, like, oh, does that look like about solar flare that's about to snap and come off?
It looks like a mini sun.
Exactly.
It looks like a sun, and it's got a big flare out of it like the sun.
It looks like a bulb from a Christmas tree, and it's got the little hook thingy where you put the hook through.
Nice.
No.
Hey, stop giving away our secrets. Just kidding.
That's interesting. Yeah, plasma is
So
interesting.
Is it what?
if the plasma is a PNP junction, if it's acting like the sun on the surface at least, normally you'd switch a PNP junction on the high side, but in like over unity stuff, like with what John Bendini would do with the NPN junction, you would actually do the opposite of what you'd think, right? So I wonder, if you basically switch on the low side as if it's a PNP junction on that surface coming out of that, basically the sphere and the rod right there, which if you timed it right with the length of whatever that terminal is and that pulse of electricity, if you can get the entire RAV to grow like a growing plasmoid, like you see in the thunderstorm generator, how they grow, like maybe you could get the energy to resonantly and harmonically amplify.
Yes, we do it with two, with a cathode that's linked to both. It just makes a U from one to the next, and the power turns into two anodes, and we can get it to pulse back and forth, and get explosion events. And in each explosion event and implosion event, you get massive energy surges, right? So that's where the energy is pulled out. One thing I will say about Bedini and what he did is when he ran the NPN, he put the light, the neon light, over the emitter and collector. So when he did that, he basically hotwired the NPN to act like a PNP. Okay, that it would actually pull it into the light itself and make the connection right there. So it acted in reverse in the way that he did the circuit right there. It's just like Gerald when he does his circuit. He puts that same light, the same neon light over it, and pulls it in reverse from the coil. So it's no longer pushing it out; it's pulling it in. It's acting like a PMP, but without the need for the resistor to be in there to trigger the circuit.
Well said.
What are those water particles that it's spewing out? I see on the side of the image. I see like little dots. Is that coming off of it?
So the ball itself is a glass ball,
Okay.
and it's 50% water, 50% air inside of it. And when it reaches equilibrium between the gases and the liquid in there, it then puts out this state right here, and you can see the plasma itself burst out from it. So it hit the point of saturation. Joe did this in a crystal as well. So yeah, that's the effect going on there. It's hitting an equilibrium point, and all that water that's in there is swirling in there as it goes. So it's making this big tornado-like effect going on in there. That's why you see dead zones and things like that.
Very interesting.
Again, this is called resonant arc vortex technology, RAV technology. Sean Calderon.
Yeah, it's pretty cool, man. They have a bunch of different shapes that comes off of this thing. This one looks like a cobra.
And well, you can see the tornado, the spin within it. And if you actually look at it, you can actually see it's a yin and yang on the top too. We're just looking at a 45-degree angle to it, and the bright to the darkness of that. And that's as it's going from the ionized light gas into the smoke and the remaining ash from it.
Yeah, it's a pretty sweet experiment, man. He's got a whole bunch of this kind of stuff. That's why we did the series, because we wanted to show every effect going on here and exactly how things built out and the way he saw it as he did it. And we just let him talk. He gets on there and he basically says exactly what it's doing. Joe and I chime in a little bit, you know what I mean? But Sean's the star of that show, man, and he deserves all the credit, and he's getting it by us putting it out there. So this is all his work, and the guy's brilliant, man. Some of the other effects that come out of this is you get to see like plasma on one side on exactly how it builds out, so that it'll create the same line that Earth does, Then you'll see a plasmoid building on that side, but on the exact opposite side, you'll see a null zone, and they have an energy exchange to each other through the sun. So it's like it's just doing a figure eight through it, you know what I mean, to the sun. It's really awesome to see exactly how that works, and it kind of goes into planetary physics when they start talking about dark spots start appearing in their solar system. They don't know what it is. Well, as you build a sun, there's got to be a dark spot to make the energy exchange. So you don't need a ninth planet, you just need that, and it'll start pulling on the gravity of the entire solar system.
And for an in-depth, full explanation, presentation, and discussion, check out again the live stream that was just done on Old Man Bill's channel earlier today.
I'll tell you this: when we go to Tesla Tech, if Sean's not able to present, I will present his RAB for him if there's time slot open.
Absolutely, absolutely.
I also think that the dark spot and the light spot is an attribute to the Aronoff bomb effect as well, because like when you have light scatter through a material, or let's say hit a wall, and like if you're shining a flashlight or a laser beam at the wall or a little piece of metal or something, in the shadow of that, you would actually have coherent light waves from either side, and you would have like this light cone that actually happens on the backside of every single planet and moon from the sun shining on any astral body. And so I think that, you know, there's these dark donuts, if you will, which actually are like conical in their shape as they project out. But within that, there's the almost the core of the apple, if you will, which is this almost oval-like shape of coherent light. And I think that the time reversal zones are like that coherent light with the Aronoff bomb effect.
Well said. Well said. I like that.
So I put up another picture, Bernie. I don't know if you can put that up.
I'm on joining by my phone, so I don't have control sadly
Oh,
right now. And Mike, I believe, is out for a cigarette, so we're gonna have to wait a moment. My apologies. I gotta for next week if I'm not back at your place, so hopefully I have better internet figured out here to get onto the computer.
I just want to show Elijah the effect. I think he'll find it very interesting on how the plasmoid builds out on the one side and the dark zone builds out on the other. And you see the
Absolutely.
RAV right in the center. Dude, it's an astonishing picture.
Mike,
The,
where are you? We know you're watching this. Get back in here.
yeah, it's. I mean, some of this stuff, man, you can't make this up. I couldn't believe some of this stuff when I saw it.
Right? Oh, I know. It's just every time Sean like experiment dumps the photos and videos on us, it's just like, oh,
Yeah.
it's amazing.
So
Have you
yeah.
guys heard of the Golden Dome? That Trump is, by the end of his term, he's gonna. It's like a dome that's supposed to protect the United States from any.
Missile shield, yes, we've heard of the missile shield called the Golden.
Well, I mean, it's kind of interesting. It's still going to be energy and energy form
Back.
that
Sorry.
you know is going to case the skies.
I'm back. Sorry.
Yeah, take a look at this. So you see the plasmoid building at the bottom on the left. Look at the top to the right. Right across from it is the dark zone. And
Oh
you
yeah,
see,
this one where it's a video and where it rotates. Oh,
yeah. Well, I just this is what I had in there right now. You can see exactly what's going on, and it's pulling in the energy from one side, so you can see it. It's an energy exchange. In the video, you see the pink plasmoid actually rotating in a circle, and so you can see how it's pulling in and out of the RAB itself and doing an exchange. That's pretty cool.
Yeah, you can literally see two destructive wake zones coming out like towards that line of where those two spheres are, right in line with that. And that's basically the wheel within the wheel within the wheel having a destructive vortex coming out of it, and that's like the hourglass, right? And that torsion is actually dilating the space and the time, creating the rainbow. And that shadow is part of the Aronoff bomb effect of all these layers of the light actually coming together within that rainbow and even where the rainbow stops. And it almost seems like there's deep infrared on one side, and then on the other side is the protium n equals 2 harmonic with ultraviolet, because that'll only show up in cameras. Like, are you seeing that purple sphere with your eyes and that bluish hue, or is that just on camera?
Oh, yeah.
From what I
That's-
know, it's in person. But I mean, we only can see it on the camera. We get it from Sean.
Yeah, so that means it's below the visual spectrum. It'll be either above 750 nanometer or below 450 nanometer. So, the visual spectrum that we could see is actually very narrow.
So I know this from creating this. I can actually see the satellites when they build out. I'll see them in the air, but then you get some of the effects in the camera. You can only see through the camera.
Yeah, when in the summertime, when I was attracting those orbs into the photos, I couldn't see it with the naked eye.
Certain things, Michael.
What's that?
Just kidding. I was just trolling you about not talking about certain things. But if you want to talk about your orbs, let's talk about Mike's orbs.
Mike's orbs. Like I said it, Mike's orbs. No, it's what's actually visible in the visual spectrum. There's a lot of people have been talking about that, not just me. So if it's below 450 nanometer, we can't see it. If it's above 750 nanometer, we can't see it. It doesn't mean it's not there. It's just our eyes are not capable of seeing it. But our cell phone cameras can. So
that's pretty cool.
Absolutely. And that's in some of Mike's orbs, there was both dark light and white light, right? You had both ends of the energy light spectrum in Mike's orbs.
I can see Mike out there in that little Indian outfit dancing around for those orbs.
He
said the rain came. I figured he did a rain dance.
Actually, speaking of which, my friend in Morocco, who makes all the, the shungite blockers for RF blockers, he just made a really cool cloud buster. And he might be sending one to me in the near future. So I might.
Don't be announcing that on live stream. And you're gonna get. Jeez.
We'll be fine. He's laughing. We'll be fine. Don't worry.
It's just cloud busting technology coming from Morocco. Nothing to worry about.
No, a lot of people have made it. It's nothing new. Oh, well, I will tell you something really cool, and I'm actually going to do it again. I made an Orgone accumulator about a year ago. Yeah, maybe more than a year ago. So here's a kind of a crazy experiment I did. I had an idea of putting the Orgone accumulator in the back trunk of my car, and my fuel efficiency went up.
Nice. That's interesting.
Because it might get you run off the road again, Mike. My God.
Little tidbits.
Yeah. Well, they have some of the old school buildings. It was kind of cool. They have insulators and stuff up there. And what they do is they normally just have the lightning go straight down to the ground. Well, they had insulators on the top of the building and wires running to them. And it was all in a video I was watching. And what they would do is collect the energy, basically pulling it out of the sky in between a capacitance between the ground, and you
Yep.
can use that as energy. And they were saying that there was proof of an old technology they had back before the 1900s. I thought it was extremely interesting because it's the same thing that Tesla was trying to do, right? When
Yep.
he was pulling the energy out of the atmosphere itself.
Hmm.
So
It's
did
nothing
they
new.
actually? Yeah, did they actually do it? Is what I'm wondering. Is I mean, because they show the evidence of
How
everything there, so
old
it's
is that working technology, right? Like, were they trying to reproduce it from previous civilizations, maybe pre-cataclysm or something, and that it was in some of those old buildings, and then maybe the cataclysm wasn't as old as it was? It just brings in so many questions. It's wild.
well, whether it was
Yeah.
or not, the technology is right there, and it's pretty apparent what it is.
Yeah.
If
There
you
is a
understand
research.
energy, it's right there.
There is an atmospheric harvesting power plant in Florida, from what I understand. It's been there for about, oh God, well over 10 years.
There's also one
And
in Alaska. It's called HARP. Just putting that
no,
out
no,
there.
no, 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 no. That's totally different.
No.
But this one is energy harvesting from the atmosphere. So they have four poles. I believe they're 300 feet each of them,
Hmm.
and they're pulling about 7 kilowatts of power out of the air.
Yeah, well, from what I understand about the video, they were putting it into flywheels,
Oh
and
yeah, that's a great idea.
yeah, put it in the flywheel and keep the
Mhm.
mechanical energy in
Mechanical
there.
battery.
Yeah.
I read a really good article and seen a couple really good videos this week. Apparently, Europe, France, and who's the other country? France is one, the big one. They have a power plant out there right now that is flywheel driven. They got about six of them.
That would
Huge.
be nice as a thing to build, Mike. If you ever get into that, let me know and I'll do it with you. But a mechanical, battery
Yeah,
like that'd
battery,
be awesome.
mechanical
Yeah.
battery. Oh hell yeah! And apparently, when it comes to like adding, I guess, more redundancy to the power grid, making it stronger if there is a failure, you got the spinning rotor that's going several thousand, RPM,
Right?
weighing several tons, right? And it's spinning, and that's energy ready on the fly in a heartbeat.
Ready
It's
on the
exactly.
flywheel.
So what they do is they put it in a cylinder and they fill it with hydrogen
Mm,
or nitrogen, usually one of the two. So there's less friction of the wheel spinning inside.
really?
It's even NASA's built one, and they're testing it up in the International Space Station as a power plant for the space station or space stations to come.
That'd be cool.
Yeah, so NASA is right on top of that one. It just looks like a tall cylinder. It's not very big. It's maybe about 18 inches in diameter, but they've had one running for about 4 years nonstop right now. And it runs on magnetic bearings. It's filled with nitrogen inside to reduce drag. And yeah, it's pumping out some serious, serious power.
So hold on, just to go back to Bedini. Bedini was saying in one of his videos that the fan on the outside was
Right,
25% mechanical energy.
right,
So why would you have a fan out there that takes resistance from the air? Why not have it to be a actual round cylinder? Not
sure.
so much a cylinder, but just
Yeah,
a round circle out there, a ring basically, in order to pull it in, because then you get the merry-go-round effect where you only have to tap it every once in a while when it slows down, but then the
right.
rest of the time it's driving over. So it would make a lot more sense. What's up, Ben?
Then,
We got a band. What up, band?
What's going on, guys? Just wanted to check
and,
in and see what everybody was up to.
yeah, we're just doing our thing, right?
Yeah.
Just
Yeah.
being
So,
Bert and Ernie, making Bernie.
yeah. So, yeah, Flywheel is definitely making a bit of a comeback in a couple of countries. They're really dumping some big coin into it. So, it's flywheels have been around over 100 years.
Yeah, but that
So,
would make a lot of sense going into something like a pulse motor if you can get it to spin a flywheel. You know what
Exactly. That's why I'm making my rotors very heavy on the outside rim.
I mean?
I'm thinking about getting a wheel cut at my work because I work with water jets. I want to cut myself a custom wheel that's going to be basically just a ring, and then I'm going to 3D print the other parts to hold the bearings and everything, and attach it, and then put the magnets on it. So 90% of the weight is going to be on the outside perimeter of the flywheel, and it should run really, really good.
Okay,
based
so
on-
aluminum Lazy Susan from Amazon has a bearing, okay? And you can get them in various sizes. There's one on the outside and one on the inside, but they have holes in them. So
Right.
you can actually take the bearing apart and use each side as a flywheel for whatever you wanted to. And you can get them like this small, you get them like this
Okay.
big. I got a bunch of
Yeah.
them. And there's a lot of weight to them. So it would actually make the perfect flywheel. And then 3D print the inside, like you said, to reduce
Yeah.
the mass on the inside and keep it on the outside.
Okay, so Lazy Susan, do you have one around that you can show? Or?
Yeah, give me a second.
All right, cool. Yeah, because I'm building the new Renegade for a friend of mine. So now that hopefully the weather is going to get better in the next month, I'm going to get working on that again. So I got to build a better flywheel. Okay.
So basically, it's this, and it has a bearing in there. You can remove the inside, this piece, okay? And you still have the outside. You can use this side or you can use this side. Doesn't matter. Take them apart. Use them together if you want more weight. But they don't just come in this size. Okay, I have them out like well over a foot on
Right.
mine. So that's what I wanted to put on my bikini because the inside here would be plastic. You know what I mean?
Yeah.
They have the holes here to hold them, and they just 3D print it out. You know what I mean? Put it on the perfect
Right.
axle. You're ready to go.
How thick is it? How thick is the?
Oh, that's at least
So a half inch. Half inch.
It's close to a half inch. Yeah.
Yeah.
Probably like 10 millimeters. Yeah.
Yeah.
You can see
Right
it's pretty thick.
So if I sandwich maybe two of them together,
I don't even think you need to. What these things are heavy, Mike.
they are heavy.
Yeah. Oh, yeah. That fan weighs nothing compared to these. Once you get it about 10 inches, yeah, I never. This one right here, this weight right here.
Yeah. Yeah.
Oh God, it's probably what 30 times what that center of the Renegade is. The spinning part. Yeah, it's way heavy. It's closer to what the coil weighs.
Right on. That's what you want.
But it gives you the adjustability. Yeah.
Yeah. Now, here's the thing interesting about flywheels. When you get them up to high speed, and if you got them, say, in a sealed container or a vacuum chamber or whatever, when you get a mass spinning at high RPM, it takes very little energy to sustain that power.
That's what I mean, the merry-go-round effect. You ever sat there on the kids' merry-go-round? They just spin you every once in a while.
Yeah, just a little.
Yeah, just when you need it.
In, right? And that's perfect for a Renegade because you don't want to waste power, right? You rather use that advantage to keep that mechanical motion, and then you have your pickup coils going all the way around. They're picking up all that flux that's just flinging off the side of the flywheel, and you're capturing that.
Yeah, so basically the flywheel's running the machine, and all you're doing is cutting off the top. Cutting the cream off the top, so you can put that into capacitance, and then every once in a while you throw another jolt of energy back to your battery to keep it running.
Yeah,
that's basically what it is.
Yeah.
That's what Timtron was trying to say the whole time when he was talking to us about over Unity. That's how he's doing it.
Yeah. Yeah. Flywheels are a big thing. Yeah. Inertia. Inertia is free energy, right?
Yeah.
Get something spinning really fast. You have potential there. And if it's got mass to it, it's got power behind it, and that will create amps.
That's right.
Right. So that's where you get your mechanical gain back into the system.
Yeah, we're on the same page there. That's why, again, I have some of these, and I wanted to use them instead of the fan. I do have the fan. I bought it. I'll put it on just for looks, but then I'm going to take it off when I start testing and really get to the point.
So I guess you could say in a pulse motor, size matters.
Yeah. I love that, Mike.
I 12 inches or nothing.
I love it. Like those big coils and 12 inches with them. Oh, that's so awesome.
Yeah.
Right on.
So I've worked with a lot of that stuff, the flywheel effect. I still think it's very valid in the pulse motor for sure.
Yeah, well, I'm
So-
hoping to find out. Absolutely.
Like Bandini says, you know, your wheel, when you spin it by hand, it should spin for about 5 minutes before it stops.
How many?
If it well, at least 5 minutes, he says. Then you got a good wheel. So
Yeah, good
that
bearings.
tells you you got to have good bearings, got to have some weight to it. You know, when he was using ferrite magnets, they got a bit of weight to them, or even ceramic ones got a bit of weight to it. So you got that on the outside edge of the wheel, that will help, you know, create that flywheel effect, right?
Oh, yeah, well, I got that on mine. Look,
Yeah.
I put
So-
exactly what he did on mine.
Yeah.
You see it right
So
there.
so you probably got about 4 or 5 pounds just in the wheel.
Oh, yeah, those magnets weigh a lot, man. That Bedini's awesome.
And when you get it up to say, you know, 300-400 RPM, it takes quite a bit of force to stop that.
Yeah, it would rotate quite a bit. I'll tell you that right now.
Yeah.
So,
Well, if you're
Definitely.
going to add mass anywhere, you want it on the outside of the wheel because then you have less
right.
G forces on that mass, so it's actually easier to attach mechanically.
Right.
And then also it's easier to balance. And then the higher frequency coincides with what I was talking about earlier with the negative energy because high frequency is a shorter time domain. And if delta H times delta T equals, or delta E times delta T equals a constant H, right? You're basically taking smaller time and you're getting more energy out. That's really what that means. That's why higher frequency light has more energy behind every photon, if you will, right? And that goes into what Ben is doing with the impulse technology as well, and with his high frequency ringing within these subharmonics. So they all coincide together with how they work on a physics level.
Yeah, the Jewel Thief circuit. Yeah.
Absolutely.
Yeah, I've always been a big fan of the Jewel Thief circuit.
It's a very
Absolutely.
circuit, to be honest.
Well, I first learned about variations of it from Takeshi Foundation like 12, 15 years ago now. And it's a key part of how the Magrav coil system works as well.
Yeah, I mean it's in the practical guide to free energy devices for a reason. You know, multiple people have utilized it, and unfortunately, those devices usually end up getting sold. But it's not that hard to understand. You know, like the basics of it are pretty simple. So
Oh yeah, yeah. I've built quite a few Jewel Thief circuits. And, you know, a lot of what's going on in a Jewel Thief is actually happening in a Renegade, but the only difference is, you know, instead of using a transistor, I'm using a make and break switch. I'm actually looking for that transient. I want that transient because
yeah, you're using a rotary pulsed waveform as opposed to the superimposed waveform, which is what you get with the spinning magnet.
Yeah, and that's why, you know, like, mind you, Tesla didn't have transistors and all the fancy stuff switching that we have now, but that's why he really focused on that spark gap. He would actually have shaped magnets inside in the area where the spark gap was happening. He calls it quenching the spark, right? So he'd actually have these magnets specifically cut for that purpose. And yeah, he was getting huge potentials coming out of it. So
In Howard Johnson's book with the magnets, he has all these magnets, bar magnets that are at an angle like this, and he overlaps the south section of the adjacent magnet with the north, right? And so they're all kind of at an angle in line like that. And then he takes a banana-shaped magnet that's north and
Right.
south. And let's say if north is up on all these barb magnets, it would actually propel down that line.
Right.
And you
And
could
the reason
actually
why,
imagine making it circular, right?
right. So the reason why he did that is I've done a lot of stuff with magnets, and you get into a scenario where the two magnets will cross each other, and there would be a spot where it becomes sticky. There's a resistance. So what he's doing with those curved magnets, with the magnets that are curved above it and the magnets below it, that spot where it's sticky, he's using the magnetic field and the way the shape of the magnets to cancel out that sticky zone. So it's one continuous flow. It's a push. And even with the Renegade, I could spin the motor or the wheel and have a magnet with it. It will pull it in from one side, but before it shoots it out the other side, it slows down. It hits that sticky zone. And that's how what Howard Johnson spent years trying to perfect, how to eliminate that sticky zone of the magnetic field, so there's no magnetic locking happening. So yeah, it was crazy stuff what he was doing. He was way beyond a lot of people when it came into magnetics and fields and how to cancellation and how to remove that sticky zone. And yeah, that was, I would say, 90% of his research, just that, because it's so difficult to, because you can't see a magnetic field unless you put a magnet on the table and throw some iron filings. You can't see those fields interacting
Well,
with each other.
Can you see the
that
magnetic field through the magnetic film?
Yeah,
Like
you
those.
can. Yeah,
Okay.
yeah, on the magnetic tape. Yeah, but to actually see that happening while it's in motion,
Mm.
how those magnetic fields are reacting. Another old trick, actually, Floyd Sweet used to do it. You take the old CRTC screens of a TV and turn it to a station where you just have the fuzzy white or just a black screen, and you could put the magnet right on the tube of the TV, and it would show the lines of flux of the magnetic fields. It actually destroys the tube when you do it too long. It actually completely destroys the tube of the TV. But yeah, he used to use that as a research tool to actually see the altering of the magnets that he was doing. So
So I have a question.
so
For a magnet, the field goes from north to south, right?
right,
Okay.
right.
Well, isn't Earth a big magnet? Why does the field go on the planet from south to north?
Well, one's more dominant for starters. One side of the field is stronger than the other, right? But there's also a bubble in the middle on either side.
Yeah.
Yeah, yeah, Elijah's. Yeah, go ahead, Elijah.
So what I was going to say with seeing the fields, you can actually see them with Hall effect sensors, and you would have to do one axis at a time in very small increments of space and log all those values, and you can map it in a computer, and you can see the dual vortex formation of all magnets, and that is the yin and the yang. And what you'll also see is that you said earlier, oh, it's just north and south, right? No, well, that's the overall structure of the flow lines of the apple core of the largest magnetohydrodynamic flow. But within that, there's other swirls. And you'll actually see that a barb magnet is not just north and south. It's actually one corner is one swirl, another corner on the north side is another swirl, and then you have counter swirls on the bottom. And it's a barb magnet would actually be four swirls. And when you look closer, there's swirls within those. And that's why you see in ancient carvings all these different swirling patterns, because the ancients were trying to preserve that in the stone of what magnetism actually is so that we could progress faster. And so the overall structure of the planet with its magnetic field lines, might look like that apple core on one side almost, but then it's like oblong because it's being berated by the particles from the sun, and it's actually charging one quadrature of our magnetic field at any given time as we're rotating. All the charged particles and photons preferentially flow towards one quadrant of our planet, and so all the ionosphere and telluric currents are being amplified preferentially along that axis, and so that quadrature field structure, just like that bar magnet, if you will, if I were to oversimplify it, one set diagonally gets amplified and is actually stronger than the other. And at some point in the middle, they cancel. And that's kind of where maybe some stickiness might happen, if you will. It's almost like the center point of the longitudinal axis of a magnetron, if you will, where all the particles want to like shoot through, is where that convergence zone is. It's like the middle point of a dual
collapse.
saddle.
It's a divergence collapse. I know Ken Wheeler talks about this, where basically the strongest part of your magnet is on the outer say it's a ring magnet. It's on the outer diameter of your magnet. That's where the strongest point of the field of that magnet is. When you get to the center where the hole is in the middle, that's where the divergence of the dielectric is collapsing there. And that's why there is no magnetism there. You might think there is, but there isn't. It's actually
I disagree with that, because when you play with iron filings and magnetic sand with those types of magnets, where it moves the most is right in the center, where you're saying there is no magnetism. But if that was the case, there would be less movement, not more movement. But in fact, they're being accelerated through that hole the most right there.
Yeah, because Ken Wheeler showed a couple of experiments, and it showed most of the magnetisms on the outer diameter. He had a really large, giant super neodymium. So
I guess what I'm saying is field superimpose, just like the triple point of an AC generator. It's super hot right there in the triple point, but you're going to measure basically like no energy. But that doesn't mean there's no energy there.
Yeah, there's a spin there. That's where the spin is.
So
in the middle.
It's like observable measurement versus like true flux, right? And the true flux of the energy density is highest at the center point, but the measurement for reductionist matter is going to be lowest at that point because of band gaps, essentially. Same idea, right?
Yeah. He has some interesting pictures actually on his website there, showing that when you take, say, two magnets and they're in a pull configuration. I might even have it on my computer. Hold on. Just bear with me here for a second. It shows two magnets. So they're in pull mode or attraction. And when they come closer together, you'll see basically two dark masses show up on either side of the magnet. But what happens is when he starts bringing them closer in, a third one shows up, and that's right in the middle. So see if I can find those pictures.
So it's kind of opposite of what you think. When you have opposing magnetic fields being forced together, the field lines actually are converging in line with each other, but they're flowing in opposite directions. And when it's in attraction mode, it's two counter-rotating vortexes that's pulling it together.
Right. Okay.
And so the collision will make that central zone you're talking about. It's like a scalar wave coming out.
Okay. Just what am I doing here?
So, and the scalar wave coming out happens with north and north coming together, just like how attraction mode does it. because a scalar wave can be either compressive or expansive, right? It can be either one.
Interesting.
Yeah.
Yeah, Michel has the paradox box, which is a super north, a north and north glued together, and I don't know. He got some interesting amplification effects with the current, so there's some
Okay,
kind of
here's that
scalar
picture.
component. I think you're right.
Okay, can you guys see my screen? All right.
Yeah.
So you got
Sure.
magnet number 1 right here, and you got magnet number 2 here. Okay. See the black hole right here? That's from the magnet on the south pole. This is the magnet on top with the hole that is the north pole. They're in attraction mode. And as you bring number 1 and number 2 closer together, there's a hole that forms in the middle. It starts coming into view. It might not be that visible. I don't know if you see that.
Oh yeah, I see it. Well, I see that.
Yeah, right there.
It's
So,
very
what?
to the round formation.
Yeah, it's the point source of attraction. So basically, that's your 0 point, and it's that area there. If you in a visualization, it would be spinning.
Well said. Well said.
So he did this in his Faro cell. So he actually
That
made it.
is the zero hole. That is the moment of Zen. That is your zero hole. That is Zen. The Zen hole right
So
there.
this is using his fair fluid lens.
Yes. Yeah. 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 That's it. Right. Go back. Yeah. So his Faro cell did those images.
So
cool.
there was a criticism somebody had of his ferrofluid lens. They said it might not be actually refracting the magnetic fields, but just the glass and the light.
You can do the same effect on. You can do the same effect actually on a CRT screen.
Okay, yeah, that would probably be better. I just know like somebody had like a criticism and they wrote like an article like criticizing his ferrofluid lens, saying they're
criticism, right?
misread results from that.
Yeah, he's kind of pissed off a few people.
Exactly.
But yeah, this is the thing about science where academia becomes so close-minded. The possibility of what he's saying is correct. You know what I mean? Because everybody just trusts academia for everything.
Wikipedia, the official debunk of it's a joke.
Right. And if you don't believe academia, whatever you believe in is pseudoscience. You know what I mean? They have to break the walls down for science. And I think honestly, the institutions now, they've kind of plateaued right now. They're not making really any kind of advancements at all, really, that are actually worth anything. They're still, based on Einstein's theories, theory of relativity, all this stuff. This is old science. In 120 years, I'm sure we have made some advancements from the old model. Like, really, honestly, like it's totally ridiculous to me to think that we haven't come up with new theories that are provable in 120 years. But academia says no. Einstein theory of relativity is everything. No, I don't believe that at all.
I think we've advanced more than I think we've advanced way more than we think we have, like, on the realms of like sci-fi stuff, like what they feed us. But the truth is a different, thing. And anything that gets leaked from whomever, they just either disappear, they die, or,
Yeah.
Yeah. So
Like those guys working on those fusion reactors, how many engineers were murdered or whatever? That happened there a couple months ago with that one guy that was working on a fusion reactor. And
yeah, they have a head of MIT's fusion reactor that got murdered, and then there's actually another scientist that was part of the one satellite up there that's all powerful one. Anywho, he got murdered in LA a few days ago, and that's
Oh,
pretty
really?
Yeah,
sad.
February
one.
16th, Curtis M., astrophysicist, got
Correct.
murdered on his doorstep.
See how this system works. Oh yeah.
So that's how it works in America.
That's
Yeah.
what happens when you keep the secret sauce behind your
Exactly.
inventions to yourself. Open sourcing really is a level of protection.
No, not
To a
really.
degree.
PSG will steal your ideas and take credit for it.
I mean,
Nobody's gonna remember
there's a
you.
way of open sourcing the science though and protecting yourself while still keeping some things to yourself, for eventual privatization. But I think, like completely keeping everything secret, that puts you in danger because you're the only one who knows the secret behind your, and makes you a target.
Yeah.
I put 90% of my theory public. I got nothing from it. PG still my ideas. Tim Ventura banned me. It doesn't work. And
I mean,
there-
it might be a little bit different for theoretical physics, though, rather than like what I'm doing with the rodent coil. But I can understand your frustration. People do want to fucking steal your ideas and shit,
exactly.
and that's
Yeah.
frustrating. So I guess that you have to take it like as a case by case. But in general, at least with what I'm doing, it really is the only way that I could do it is open sourcing, at least most of it, as much as I can.
I think the ultimate way is to have a company to bootstrap your company. It's not easy, but I think that's the only way that nobody's
I
gonna
mean,
mess with you.
ideally, it would be a good way, but I mean, I just don't have the investments for that kind of.
That's the thing. Bootstrap company. You don't need investors. You finance your own company with something else. You know.
I think I'm gonna try to apply for a couple of grants. That's what I'm
Yeah.
gonna.
I was talking about grants. I was talking about grants earlier.
Mhm.
For deep tech, you have to apply with DARPA. The other companies, you need to find a solicitation and apply for SBIR, STTR program. It's very consistent in the United States compared to Canada. Canada is there's too much discretion.
So
Turns
it's too
out,
much red tape over there regarding that shit.
yeah, they change it all the time, and I can guarantee you, if you did not vote for the current government, they will make your life miserable. That's exactly what happened to me. I can prove it. That's the way it is these days. They can tell who you voted for, even if they don't know your ballot. They will see your online post. They will figure it out.
Well, the whole thing went digital, so of course they have, who votes what. It's not
Yeah,
paper
exactly.
ballot anymore. It's a digital system. So yeah, they
Well,
can
Yeah.
no,
change all that.
where I live, we actually had a paper ballot.
Oh,
No,
in
no,
Canada, okay.
no. In Canada, they still use the Dominion voting system.
Yeah.
Which is Venezuelan based, correct.
Yeah, and we didn't fight against it. We didn't do anything, so we're stuck with it.
What's that you're showing, Bernie?
Just out of the Browns Gas Book 2 by George Wiseman. And this right here, we are looking through. I'm at the Tesla Tech archives, and my God, history of hydrogen. You best believe Bernie's getting educated in exactly the science. You know it, educated. And then we got ultrasonic water technology. We got Tesla's engine. We have T field energy research. We have Geet single auto conversion plans. And we also have Extraordinary Science and Technology magazines. These are actually for sale. And with certain orders right now, you will get some free. And if you want to attend Tesla Tech, the site conference in person, Albuquerque, New Mexico, August 12th to 16th, where we have open source to the max with so many specialists in these fields. It's 40% off at teslatech.info. That's www.teslatech.info right now for the next 2 weeks. Tickets are still 40% off. And it is at the Crown Plaza Hotel in Albuquerque. A great, great time. So, yeah, just showing some of this stuff off right now. And also for sale, Growing Gold. How to do it through a microwave oven and glass.
And you're talking about me
Right?
putting a
Like,
target on my back.
we
Jesus.
have all the secrets, particle mechanics, the theory of energy states, microscopic, macroscopic, quantum vacuum. We have all sorts of everything you could dream of, from Brown's gas all the way to electrons by the ascended masters. There's everything in the Tesla Tech archives. So yeah, that's my little spiel.
Very
My little
cool.
spiel where I'm at here. And I'm in Nevada, but it's in New Mexico in Albuquerque. You want to be there in August.
Oh, Mr. Ben dropped off. Comes in, he goes out.
If I were you, I'd be scanning all of those and uploading it to Drive and thumb drives and printing copies and sharing the copies and sharing
And
all the PDFs.
we can
Yeah,
use Elijah. You're welcome to come down and help with it. And I am taking copies. I am scanning. We're trying to get as much of it up. And there's so much here. It's crazy.
Well, I would if I could, but I literally can't. So
Fair enough. Well, I can, and I am, and I will be sharing with all of you. Don't you worry. So as it becomes available, as we get it done, I will make it available to you.
I got a pretty
Looking
large
forward to
archive of stuff too. Yeah,
All right.
and,
Well, I love you all. I should probably drop out here just because I'm using up a sheet ton of my bandwidth on my roaming cell phone for Canada. So always a pleasure, and we'll see you on the next one.
all right. Talk to you soon.
He could have bought like from Verizon's $10 to have Wi-Fi.
Yeah, I know.
How
Oh,
about
man, he's got a huge bill.
how about connecting to a Wi-Fi? You know, that's what I'm doing.
No, yeah, but they like sell it for like $10 for personal Wi-Fi if you need it.
Yeah.
No, but
Yeah,
you go to a cafe somewhere and you connect. You know.
Mm. I have like my own personal Wi-Fi that if I keep with me just in case, like a little, little box.
Yep. I did that when I was at the Philippines. They have the cards that you put in and you can buy time on it, like pay as you go kind of thing. It was called Smart Buddy, right?
Mm-hmm.
So I saved a ton of money when I was down there. I had Roger's phone at the time, right? And here's the irony of the whole thing. I was like in like the friggin' Amazon rainforest in the South Philippines on a friggin' raft. And I had better connectivity than I do here in Toronto.
Because there's no disturbance of other things there.
No,
So
what they
you get a
do.
clear signal, and
Know why they have such a good signal there? They were smart. They put all their cell phone towers on the tops of the peaks of the mountains in that area. So the coverage is amazing. I have full bars.
Cool.
Like full bars. And I'm like in an Amazon rainforest. I can believe it. I'm like, am I seeing things? Because I got a perfect signal.
Very cool.
I'm on a raft and there's friggin' gators going by and stuff like that. And I got a full friggin' signal. It's hilarious.
So sorry, I don't understand. Mike does ask me if I'm related to Stallone, Sylvester Stallone. Who's Stallone?
Sylvester Stallone. Why is that? I don't see how you look like Sylvester Stallone.
Look in the comments. I have no idea Which Stallone is
I don't
talking
know.
about?
Is he making comments about your gray hair or something?
I don't know.
Or
I,
is it the accent? I don't know.
The
I,
accent.
it's funny.
Stallone does.
Yeah, that's where you good
Stallone
point.
doesn't have a French accent. Sorry, I don't
Well, I
see
mean,
the
I know he doesn't, but he's just,
similarities
I
there.
don't know, like what he's comparing, but yeah.
When my skin gets darker, because I my skin get darker very fast when I'm in the south,
Yeah,
and people
my
ask
skin
me
gets super dark too.
people ask me where I'm from, and I keep saying, "Oh, I'm from Brazil," or something like that, and they believe me.
You're from Brazil. Yeah. No, but like my skin, by the end of the summer, I'm like really dark. Like I'm European background, right? My skin goes really dark.
Yeah, exactly.
My
Yeah.
wife, my wife and my daughter, they're whiter than I am, and I'm the white guy in the family. My wife's Filipino, right? So you would think naturally she's darker skin. She's white. I'm like darker than her. It's hilarious. I bug her
Yeah.
about it too.
Cheers. I
Yeah.
cannot talk too much, but cheers. I'm
But
listening to you guys.
oh, okay. You're
If there's
leaving or are
more,
you staying? Well,
no,
we're almost done. We got another 15 minutes and then we're done for the night.
I
Yeah.
stay, but we share the sound, with multiple people here, so that's why.
Uh, yeah. I guess talk about my batteries a little bit. What I'm going to be doing is they use the lithography, they call it, where they use like a foil paper and then they laminate these coatings on. Well, those machines are extremely expensive. I found a miniature one that's about this big, and it's like $18,000, like extremely expensive. So I don't have that money. So I got to come up with a different way because they're making layers. 10 years ago it was 20 nanometer. Now they've got the layer thicknesses down to 2 nanometer, which is really thin. So I start doing some chat GPT on ideas of actually airbrushing actual layers. So I've been coming up with some formulations to actually use my airbrush to create the layers of the battery. So, and it's giving me positive feedback saying, yeah, you're going to get good energy density. Um, um, it's going to be a high voltages. You'll have very little losses. You'll have lower battery resistance, internal resistance. That's actually 1 meter I want to buy is a battery resistance ohm meter that's built for testing batteries out. So I might actually get it. It's about $100. I'm going to get one of those so I can test my batteries with the internal resistance of the battery. So I'm coming up with these new formulations. I actually have a really nice airbrush kit. And since I figure out those formulas, I'm going to start airbrushing my batteries. So I'll get each layer down to a very thin layer. So it'll change the whole dynamics of my battery technology. So what do you think about that, Elijah?
I think the airbrush will provide a thin layer, but it's not going to be even. And it's going to be difficult to get that crystalline structure to be really even. Part of it will be amorphous, but that could also provide an advantage because it might act more like a broadband amplifier in that zone instead of just tuning into one signal. Like you can have more access to a slightly broader range of frequencies in that section, right? So it might not even be a negative thing in that regard if you're trying to access all the little transient fields of the environment. So it might work better than something that's more perfect, actually.
Yeah, because like in realistic, I can afford a $40,000 machine or $20,000 machine that does that. So I have to work with what I have as, an experimenter, So my airbrush that I have actually can do some really, really thin layers. And if I get it tuned right or I get my technique where it's just right to make the layers really good, who knows? I might be able to get better results than I might think I would, right? So, hey, I won't know until I try. So I'm definitely going to try it because I got all the equipment to do it. So
I would make a rig to where you can, similar to how a 3D printer can go X, Y, Z axis,
yeah,
like
yeah.
lock in your Z axis and just
Oh, I see what
pan
you're
on the
saying.
X, Y axis and just do like layer and then a set distance, like
Right.
from that. And because you're going to have overlap of spray, right? So
Right.
you got to also time how quick it's going across. And you
Yeah.
can use like a little motor and you can play around with all those factors of like distance away, the pressure you're going in. And
Actually, you know
you're
what? I
definitely going
have
to want like a laminar stream flow. So you're not going to want to push it with a high velocity stream out of that nozzle because that'll create turbulence and you'll get asymmetrical
right.
layering, right?
Yeah. Because I have a 3D printer, I could also jerry rig it to actually hold a airbrush and then create the G code so it does like a pattern,
Yeah.
and then adjust it that way and make sure the Z offset is at a certain height, so the stream coming and how far it disperses, like this, will be consistent and with the strokes of the X and Y passes that it makes. Yeah, maybe I could come up with something kind of neat.
And you might have to play with like how close those passes are to each other with how much of the stream is overlapping because more of the center of the stream is more dense, right? So
Yeah.
by overlapping the edge of the stream a little bit, you could actually kind of get the whole surface more even that way.
Right. Or if I can pull it off, make it as just one swipe, one
Right.
consistent right across. If I can
But that
pull
would
that
be
off,
like more concentrated in the center unless you can design a specific nozzle that's like a fan almost.
yeah, because the airbrush that I have, I can actually adjust the actual flow, like the flow control of that. I can adjust the needle inside, how much it's going to disperse uh, the fluid through the needle, and yeah, they're pretty fine tuned now. You can really adjust them quite well. The airbrushes are a lot better than they used to be 20 years ago. That's for sure. And I
Okay.
got a to date one, so I should be able to control a really good flow. And if I could get it in one pass and actually get it down to like say, a few nanometers, that'd be like right on. I might be onto something there. For a hobbyist to make a battery, not have access to, you know, 40, 50, $100,000 machine that does that.
And for the graphite layer, if you're making any of those, you can get like a really thin layer by just burning like methane and letting the
Yeah.
soot accumulate.
Yeah.
Yeah.
Well, I have a really good recipe for graphene. I use a process of exfoliation in an ultrasonic cleaner, and
Right.
and all I do is after I refine it down to a graphene state, then I add a little bit of India ink, and that's my binder. And India, if anybody knows what India ink is, as soon as you get it on you, it's not coming off. It's extremely bondable. So I'll be using probably the surface I'll use is a foil, a really good foil. And do a graphene layer on the foil. And then after that, let it thoroughly dry. And after it thoroughly dries, then start doing my layers of what I want to put, all the different elements that we've been talking about off air. So yeah, I'll try that out and see how it works.
The advantage of the combustion method would be that you'd get more of a continual layer of the material
Graphene
instead of
oxide.
little specks like here and there and within that ink, right?
Yeah.
So one would act more like a metasilicate, which would be your version, and the other
Yeah.
would act more like a Bose-Einstein condensate, which would be the soot version.
Right. Because like the mixture I've made, I've got it down as low as 10 ohms resist. So 10 ohms not bad. I like to get it down to about 2 ohms. So yeah, I'll try it out, see what happens.
I think that 10 ohms is close to your like anti-gravity wave according to Rick Mueller. And he said 11 ohms, but I don't know anything about that impedance matching for gravity waves or anything, but according to him, he seems to think that that's kind of the range.
Oh yeah, that it'll actually interact with it at a 10 ohm resistance.
Yeah, he said 11, but 10's pretty
11.
close. If I
Interesting. I
recall
never even
correctly.
thought about that. So what could I do with that if I'm interacting with a gravity wave?
I think it's a sort of a version of an impedance matching to where, like, with every difference in density, you get a reflection, a partial reflection, and you also get refraction. And so something about these different layers of impedance can access different frequencies or different things. And so, like, I don't really know how that side of it works with the gravity wave thing I mentioned, honestly. But what I do know is that you can tune your band gap and your impedance to access different light frequencies optically.
Remember we were talking about this when we were doing the messenger chat there last week? It was bismuth that he was working with. He was bonding bismuth and magnesium together.
Yeah, so bismuth has got the spiral flows, and I believe it has some sort of asymmetrical spin to it, if I believe correctly. And if you have spin 2, that's basically like no torsion. And if you have above or below spin 2, you'll have torsion, right? And you look at the macro structure of bismuth, and it is torsion, right? So I would deduce that it's the negative entropy or time reversal wave property of its spin.
Well, bismuth is one of the best diamagnetic materials, right? It hates magnetism. It repels it. Like you could get that graphene wafers that are diamagnetic, and if you put it in between two magnetic fields, it repulses it, pushes it away. It just doesn't attract it at all. There's no attraction. It repels the magnetic field. So it's diamagnetic.
I'm not sure, but I do know that if you try to spark through bismuth, if it doesn't vaporize, the spark will be like a discharge, will be like a sizzling effect similar to bronze. I do know that from just messing with it.
Really? Bronze?
What about tin? They use tin in like lithography, as a layer on the the chips. So would that work? If you
Titanium has tin in it as well. I was actually cutting some titanium this week.
Well, it depends on what you're trying to do. Like, work for what? Like, get more power out of it?
Or strength. Lulu, are you talking about like the strength of the material, or
No, I'm talking about layering it. Like layering the nanometers.
Well, that's what I'm going to be doing with the battery. That's the idea. Yeah.
I would do like a metasilicate, or silicon dioxide, and then your silicon carbide, and then maybe like carbon, And then you can have like a layer in between that's another silicon dioxide or even glass, and then another metal with a difference in electron value, like tin would work. And then you could have a larger cavity of like doped glass, and then like an aluminum mirror that has that nuclear magnetic resonance and
Yeah.
reflection, and that asymmetrical uh, cavity will make an nonlinear oscillating, to where at those high frequencies of the nanometer layers, the anode and the cathode will form a dipole and
Right.
start structuring the little frequencies of the thermal vibration, as well as any photons or virtual photons coming in,
Right.
into a real charge, and that appears to be an electron tunneling. And so I think tin could work. All you need is a difference in electron values and
Mhm.
geometry, right? And you don't need the galvanic action necessarily. And if you really wanted to get into like certain energies like neutrino or solitons, you could use gadolinium, but it's really expensive, right?
Yeah.
And so, that's why I mentioned carbon as a layer, or activated carbon or graphite or something like that, because it could be your neutrino flux mediator, and you'll be able to use it as a penning trap as well, to where it's a particle oscillator within that, to where now it's on its own, providing continuous like LC circuit behavior for, let's say, tin to mediate with, to where essentially that um, tin could be excited a little bit off of it, right? So you don't need necessarily the Gibbs free energy to be reached, because of what's called Marcus theory. So if you align something like an NP junction really close to each other, and what happens is it's kind of like looking down all the rows of an orchard at once, instead of just one direction of the rows, to where the light converges, and the light of the orbital actually starts stacking in phase alignment. And that is how you can get resonance to build up that's sub-ionizing and sub-Gibbs free energy, to stack the energy levels to actually make the probability of an electron teleporting go to 100%. So tin could work, and so could many different elements. It's about how you stack it with your band gaps and the geometry and everything, to access different frequencies of what you want, right? So it's kind of like tuning into the universe. It's like, what do you want to tune into? And you can make like a broadband amplifier effect, where you're kind of tuning into everything like a megaphone. So that's the beauty of a megaphone, is its conical structure, is it's making it louder because it's a broadband amplifier. So if you're going to make a stack, you want it to behave kind of like that.
Actually, I just want to jump in here for a second. I found some interesting information. So, I use magnesium a lot in my batteries, and I wanted a little bit more information regarding magnesium versus lithium. So, listen to this. So, lithium has 3 protons. Okay, magnesium has 12. Okay, so the charge carriers, lithium will give up one charge electron carrier, where magnesium will give up 2 electron charges. See a trend here? So the atomic weight is 6.9 for lithium, and magnesium's a little bit heavier. It's 24.3. Now, let's see, we got energy by weight. Um, yeah, so when it comes to like chart,
That's so cool.
Yeah, it's way higher. Like there's
Wait,
12 protons versus 9 protons from a lithium.
that's going into the 333 hertz that Tesla was talking about, the 3.33 ratio.
Got it.
Now I get what
Yeah.
you're doing, what you're talking about.
Yes. Yes. Exactly. You caught on. Awesome. Yep, that's exactly where I was going. So that's why I'm using magnesium. When it comes to lithium, magnesium's a lot more stable than lithium. Yes, it's heavier. Okay, you know, can't be perfect, but when it comes down to charge carriers and the amount of protons and electrons that are released is a lot higher than lithium by mass. So magnesium, I don't know why people are not using it. I really don't understand it. Why is lithium been used as the you know number one source of material for the batteries? They should have been focusing on magnesium. Well, sodium's good too, but magnesium's been around forever. It's easy to get. It there's a lot of it. You know what I mean? But it's expensive because they made it that way. It's not in demand. You know, yeah, I don't know. What do you think, Elijah, on this versus lithium and magnesium?
Well, I think we got to pay attention to history and the Great Pyramids when we're talking about magnesium, because they made their limestone blocks insulating on the outside without magnesium, and anything on the inside that wasn't lining the empty cavities, that wasn't the piezoelectric granite, right, was
Yeah,
a
it's
geopolymer limestone with magnesium in it, because it's
yes,
conductive. And they were tapping the radio frequencies and the Schumann resonant frequencies, and making a big static electric and chemical uh, reaction machine that was also piezoelectric in its chambers, with the hydrogen production bursting in the King's chamber. And so I think it's wise to use magnesium in a dielectric cell if it's interacting with water, because magnesium and water work really well together. Anytime you have something like copper and hydrogen, for example, it works really well together because it resists the diffusion of the hydrogen within it. And so, we build circuits out of copper all the time. And so using cells that access the humidity of the air or in water, amplifying your cell by putting it in water, for example, magnesium is a great choice.
Yeah. And I've had some cells put out over 500 milliamps. And the cell's only like size of a credit card.
Somebody in the chat, somebody in the chat said, like, the magnesium, they don't use it much because it's used as like fire starter.
Yeah, but magnesium's flash point's 900 degrees. So if your battery's heating up to 900 degrees, there's something wrong with the battery. You know what I mean? Like it's shorted out, or you get dendrite problem. You get the thermal runaway. But lithium is actually higher on the periodic table. It's one level higher than magnesium. So yeah, like when it comes to safety, actually magnesium's a better choice, safety wise.
Well, magnesium is going to attract any paramagnetic material like oxygen, and it's going to go on that surface. And so it's going to prevent galvanic action because of the paramagnetic material with the metal, right? And so, if you were in a vacuum type situation, like, it would honestly want to galvanize, right? We don't want it galvanized. We just want nonlinear oscillation to structure coherent energy into electron pairs, similar to the Bethe-Hilter process, right?
Interesting. Well, guys, we're past 11 here. I got to get up early. I have to get some tests done tomorrow. with the doctors. Yeah, so everybody, thanks a lot. Live chat was great. We go live to her again next Friday at 9 o'clock Eastern. I'd like to thank Elijah for joining us, Philip and Lulu and Nathan and Bernie. Thanks for being a part of the show tonight, and also Ben. We haven't seen him in a while. Everybody have a great weekend. Any questions, comments, you can contact me at Faraday Research on YouTube, and we'll see everybody soon.
Don't miss the World Championship in hockey on Sunday morning.
Oh,
Canada
yeah, right.
versus the United States.
Yeah. All right, guys. Have a great night.
Cheers.
Good night.
Cheers.
Cheers.